Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Muzammil bin Muhammad Saifunnizam and my metric number is 2313233. I will begin by presenting a brief introduction on our project. Artificial intelligence (AI) continues to transform the environment of early childhood education by enabling data-driven decision-making and personalized learning experience. Machine learning approaches can discover learning patterns and developmental concerns early on, allowing educators and parents to respond more effectively. The objective of this report is to investigate the development and evaluation of a supervised learning model, specifically a random forest classifier to determine if a young learner is at risk or on track, based on behavioral and educational characteristics. Through this project, we aim to demonstrate how AI can be harnessed to support early learning interventions and contribute to more equitable and responsive educational system.
Okay, I will be explaining the dataset we use in this project. We are using a dataset called Student Performance. It comes from the UCI Machine Learning Repository, which is a popular set for machine learning datasets. This dataset includes information about students in a particular school. Each row in the data represents one student. We have details like their age, study time, grades, and whether they get support from their family. The main goal of our project is to predict if a student is on track or at risk of failing. So to do that, we created a new column called learning status. We base it on the student's final grade called G3. If their grade is below 10, we mark them as at risk, which is value 0. And if it's 10 or above, we mark them as on track, which is value 1. We only use a few important columns for our model: age, study time, two earlier grades, G1 and G2, and family support. Also, since some of the values were in text like yes or no, we changed them into numbers so the model can understand. There were no missing values, so we didn't need to do any cleaning there. And that is the basic overview of our dataset. Now I will pass it to the next presenter to show some analysis and graph.
Assalamualaikum. I'll begin by explaining how we allotted and prepared our data. We use the UCI Student Performance Dataset, which contains academic, demographic, and family-related information. Our script starts by fetching this dataset and combining the features and targets using the UCI ML repo library. Next, we define a new binary target variable called learning status. If a student's final grade G3 is below 10, they are labeled as at risk, which is 0. Otherwise, they are on track, which is 1. We selected 5 important features such as age, study time, first and second period grades, G2 and G2, G1 and G2, and family support. We renamed them for clarity and also converted the categorical variable for parental involvement into numerical format. This pre-processing ensures that our neural network can properly learn from the data. Lastly, we printed a sample of the processed data to visually confirm that the transformation was successful.
So thank you. I will now explain the exploratory data analysis. So first of all, we started by printing descriptive statistics of the dataset to understand the overall distribution and central values of our selected features. And then we use a count plot to visualize the balance between the at-risk and on-track students. So this will help us to see if the dataset is imbalanced, which can affect model performance. And then we also plotted a heat map to show correlations between features. As expected, literacy and numeracy score, which is G1 and G2, showed a strong positive correlation with the final outcome. And lastly, we use histograms with KDE plots to show the distributions of each feature. So this will help us identify skewness and variability in features like age or study time. And all in all, this visualization help us better understanding before we move to the model training.
Assalamualaikum. I will explain the training process using a neural network. We use MLP classifier from scikit-learn, which stands for multi-layer perceptron. This is a type of feed-forward neural network that can model complex relationships. We split the dataset into 80% for training and 20% for testing. Our network had two hidden layers with 50 and 30 neurons. used the value activation function and was trained using the Adam optimizer. The training process ran for a maximum of 500 iterations to ensure convergence. This neural network was chosen over random forest to explore deeper nonlinear relationships. It is slightly harder to interpret but can capture more subtle pattern in educational data.
Assalamualaikum, my name is Muhammad Khalif bin Zakaria. My mature number is 2318591. So, I will explain the evaluation of our neural network model and summarize our overall results. So, after the training model, so we evaluate it using multiple standard metrics. The evaluation process is handled in the evaluate model function as in the code. So, first we use the train model to make the prediction on the test set. So, this prediction will compare with the actual label using accuracy score to compare the average accuracy. So I will show the accuracy score next at the result. So next we print a classification report. So this report show precision, recall, and F1 score for both classes, either at risk or on track. So precision measure how many students predicted as at risk were actually at risk. Recall measure how many of the actual at risk students were correctly identified. The F1 score combined both precision and recall for balanced evaluation. So for our model, both classes had precision and recall above 80%, and the F1 score was strong, indicating balance and reliable classification. So we also plot a confusion matrix to visually inspect the prediction result. So I will show the confusion matrix later. So and lastly, we conduct also the 5 for cross validation using the cross val score, as we can see at the function. This helps us to measure how well the model generalizes the unseen data. Each fault tests the model on the different subset of the data. So next. So these are our output of our results for our code that we have been done. So the first one is we generate the descriptive statistics, so we can know the count, the mean, and the standard deviation, the mean, and how max. So the first one is kind of like we can see at the age, the mean of the age at 16.74. So we know that the average age for our data set is at 16 years old or 17 years old. And also we generate a sample of the process data. You can see that it show that for 5 sample data at 18 years old, 17 years old, 15 years old, and 16 years old. And then you can see the accuracy of our code at 92.31%. And also at the classification report, it showed that the precision, recall, and Fonsco support for the at risk or on track. The 0 is indicate the at risk and 1 is indicate at the on track. So and then we can see the cross validation result at the bottom. So the mean severe accuracy is at 191.37%. So it's kind of strong uh, strong accuracy. So the results show mean cross validation accuracy at 91.32%, so meaning our model perform consistently and reliably across different data splits. So you can see also at the right side, we also do the facial correlation matrix, the correlation between one subject to one subject. Like you can see that at the numeracy score and the literacy score, it indicates 0.86. So it's kind of a good or a strong in correlation. So it's mean like someone that good in math also can good in the language. But also you can see at the parental involvement, it's kind of maybe the parental is kind of less. So there is a uh, not good not good correlation between the what the study with the parental involvement. So for the last slide for our output, there is two like we also generate the distribution of age, attention span, literacy score, literacy score, and parental involvement. So you can see at distribution of age, it distribute more at the 70 years old and 16 years old. So it accurate with our mean before that at 16.74 years old. At the attention span also is kind of right skewed. So the highest hours they study at 2 hours, and also we generate the confusion matrix. So at the confusion matrix, you can see that X students were correctly identified at risk. 112 students were correctly identified as on track, but 3 students were misclassified as at risk, and 7 were
misclassified as on track. To conclude our project, so this project successfully developed a supervised learning model using random forest for early learning intervention. So the model demonstrates reliable performance, offering a useful tool for identifying students who are at risk or may need additional support. So the project enhanced our understanding of supervised learning and its real-world applications. So that's all from us. Thank you.